go ahead and let's talk about Lesson 2, functions. So first page, you find vocabulary startup and asks you to define an independent and a dependent variable. All right, and that's in your own words because you have a box that says independent variable, what I think it means, dependent variable, what I think it means. And we've already talked about this a little bit in class, so I'm going to go ahead, put a D and an I. So D is for dependent variable, I is for the independent variable. Now usually what we see when we graph these things is that the x-axis has our independent variable and our y value, and the y-axis is where we measure our dependent variable. So the reason why we have that is because typically whatever happens to x happens to x. It doesn't depend on anything else. So in this particular scenario, we're going to have to give us m equals 20n about mowing lawns, right? So the number of lawns you mow doesn't depend on anything else. You mow 0 lawns, you don't make any money. You mow 1 lawn, you make $20. You mow 2 lawns, you make $40, all right? Now in this scenario, obviously, we're dealing with money, so you can't make negative money mowing lawns. It would be greater than or equal to 0 along the x-axis. It doesn't make any sense to try to measure negative x values, but we talk about y being dependent upon x because really y is meaningless without the x information to fill it in and round it out, right? So once we know how many lawns we mow, then we can multiply that by 20, and that tells us how much money we've earned. So the dependent variable, essentially, it derives its meaning from its relationship with the independent variable. All right, so they give us 3 equations. So they say C equals 0.99 n, and this represents a total cost, C, for n music downloads. So the independent variable here is the n. The dependent variable is the C. The next one they give us, the equation D, equals 4.5, equals 4.5h, represents the number of miles D that Amber can run in H hours. So the number of miles that she can run depends on the number of hours that she's been running. So H is our independent variable, D is our dependent variable. All right, the last one we're given is S equals G plus 3. So we have S equals G plus 3, represents the final score of the game after G goals in the final period. All right, so this right here is a linear equation. All right, G plus 3. So S is our dependent variable because in our final period, we're going to be adding some goals to the number 3. So G is our independent variable. All right, because it is what it is. And S ends up becoming something meaningful based on whatever happens to that variable G. So G is independent, S is dependent. All right, that's page 377. So I'm going to flip in my book to 378. So if you're pacing yourself, this is something you should have done your first day with this lesson. All right, second day, we're going to do a Zoom session today. And what's going to happen with this is we're going to go over the stuff you should have done yesterday. I'm going to prep you for the material today. You just have to make sure that your pacing is good. All right, so the top of this page, they give us some information, they give us some definitions, they give us some function notation. So they tell us that this is read as the function of x, or f of x, all right? That's equal to 15x. So x is our input, right? It's our independent variable. It's also known as our domain. All right, so f of x is really, that's really our y. It's really our output. And we call this our range. All right, example 1, they ask us to find f of negative 3 if f of x equals 2x plus 1. All right, so think about it like this. All right, so 2x plus 1 is a rule. It tells us that if we input some value for x and we follow this rule, 2x plus 1, that's going to create an output value over here on the other side. Now, how do we know what value to put in for x? In this case, they tell us they want f of negative 3. So we do substitution. All right, so what happens here is, where we had x, we substitute negative 3 in. So 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. All right, guys? So if we're looking for f of negative 3, when f of x is 2x plus 1, or f of negative 3 is equal to negative 5. And you can actually write this as a coordinate pair, right? Since negative 3 is our x, and our output, or our dependent variable y, after we substitute x in, works out to negative 5, we have the coordinate pair negative 3, negative 5. Right, now that's example 1. So they give us the opportunity with A to try to find f of 2 when f of x is equal to x minus 4. So once again, so this is our rule, right? So we substitute 2 in here. So f of 2 means instead of x minus 4, we're given a specific x to plug in, and what happens is that generates an output value of negative 2. All right, so the value of this function when x is 2 is negative 2. All right, for B, they want us to find the value of this function, f of x equals 1/2 x plus 5, when x is 11. All right, so what we do is we substitute that in. So f of 11 means that wherever we have an x in our original function, we substitute an 11 in for that. So we have 11 halves plus 5. 11 halves is really 5.5. So that's really 21 halves, or 10.5. All right, guys, now they say at the bottom of page 378, example 2 leads us into function tables. So a function table allows us to take a look at and compare the relationship between the independent and the dependent variables. All right, because we have them separated this time by our rules. We have domain, we have range, and we have our rule. Now in this case, they say choose 4 values to make a function table for f of x equals x plus 5. And those values we're choosing are x values. You don't want to go crazy with it. You don't want to be ridiculous and say like, 30 million or negative 17,000. Let's just, for 4 values, your book does this, negative 2, negative 1, 0, and 1. That's absolutely fine. All right, because our domain is our x, our range is y, we're f of x, but f of x is just telling us that y has been placed into function notation. All right, so what the rule means here is I'm taking these domain values, negative 2, and I'm substituting that in where I see x in our rule. For negative 1, I'm substituting that in for x. For 0, I'm substituting that in for x. And for 1, I'm substituting that in for x. And when that happens, we can now evaluate. So 5 minus 2 is 3. 5 minus 1 is 4. 5 plus 0 is 5. And 5 plus 1 is 6. Right? So what we've just done is we've taken an x value, a domain, we've substituted it into a rule, and we've generated an output. So eventually what's going to happen with this, guys, and I hope you see it, is we're going to take these, and we're creating points, which we're then going to be able to graph, and we're going to be able to talk about what these things mean in specific real-world situations. Okay, so just as we get comfortable with that, they say, here's a rule, f of x equals x minus 7. So we need our domain, and we need our range, and we want 4 values. So this time, why don't we do negative 1, 0, 1, and 2? All right, so x minus 7. So I'm going to substitute in negative 1 minus 7. If x is 0, my rule is 0 minus 7. If x is 1, my rule now becomes 1 minus 7, 2 minus 7. Right, so negative 1 plus negative 7 is negative 8. 0 minus 7 is negative 7. 1 minus 7 is negative 6. 2 minus 7 is negative 5. All right, and down the road, we're going to take these numbers, and we're going to put them together like so. You don't need to be able to do this right now. Just understand that down the road, that's coming. So Algebra 1, you're going to be expected to know how to do this and take your work to this level so that you can think and reason through some problems that are based on your work with the function rule. All right? They get us into that with the next 3 examples. They say there are approximately 770 peanuts in a jar of peanut butter. All right, must be some chunky peanut butter, right? Peanut butter. That's 770 peanuts. The total number of peanuts in a jar is a function of the number of jars of peanut butter J. Identify the independent and dependent variables. All right, so dependent variable is going to be P. Our independent variable is going to be J. All right, now what values, so that's example 3, what values example 4 are going to make sense in this situation? All right, so in terms of my independent variable, if they tell us that approximately 770 peanuts are in 1 jar, then I'm not going to have a negative amount of jars, right? That's a little bit absurd. I can have 0 jars of peanut butter, right? I can have 1, I can have 2, I can have as many as I want to the right of 0. I'm not going to have a negative number of jars. That's ridiculous. So our domain is going to have to be greater than or equal to 0. Likewise, for our range, our total number of peanuts being a function of the number of jars of peanut butter, that also is going to have to be greater than or equal to 0. Because if we don't have a jar, we're not going to have any peanuts right there, so you can't go below 0. All right, I hope that makes sense to you guys. Now let's look at 5. Write a function to represent the total number of peanuts, then determine the number of peanuts in 7 jars of peanut butter. Well, to start, we know our 2 variables, P and J. So we know that P of J is equal to something, right? J's number of jars. Now, they gave us some other information at the top. They said there are approximately 770 peanuts in 1 jar of peanut butter. So P of J is equal to 770J. All right, that's our rule. Now, how many peanuts are in 7 jars? So P of J becomes P of 7 because we have a specific number, right, that's now being grounded in a particular context. So what do we have here? 770 times 7. Come on over here, guys, to your calculator. 770 times 7. Now, you can break it apart and do it in your head, right? 4,900 plus 490. If you break 770 up into 770, and you add those together, you get 5390. So what I'm saying is you can use the fact that 770 can be broken up into 700 plus 70. If you want to do this out by hand, you can do it this way, practicing the distributive property. All right, but ultimately what's important here is that in 7 jars, we have 5,390 peanuts. Oh, by the way, I've mentioned this in class before. Units are going to be important right here for dimensional analysis, right? 5,390 what? Inches, miles, miles per hour, peanuts, all right? We have a specific context. So peanuts right there, that's the unit that we need to have with our answer. If you don't put that there, you have to count that wrong. All right, and let's take a look at one more thing right now before our Zoom conversation tomorrow. They give us a got it, and the got it deals with scrapbooking. The scrapbooking store is selling rubber stamps for $4.95 each. The total sales, right, F of N, is a function of the number of rubber stamps N sold. So first off, they want us to identify dependent and independent variables. Independent variable is our X, which here is N, it's the number of stamps, rubber stamps sold. Our dependent variable, so what depends on that number? Well, F. Okay, because we're looking at F of N right there. Now, what values in the domain of range make sense for this situation? Like with our other problem, if you don't buy a stamp, you don't pay any money. You're not going to pay negative money for anything. So you're going from 0 and you're increasing in a positive direction. All right, so what makes sense for domain and range? Values that are greater than or equal to 0. All right, so this is D, this is E. And if write a function to represent the total sales, F of N equals 495N, and I want to know how much is it going to cost us if we get 5 rubber stamps. Right, so that's going to be F of 5 equals 495 times 5. All right, so 495 times 5, it's going to be $24 and 75 cents. $24.75, guys. All right. So we'll look at the guided practice really quickly, and then we'll be done with this first video. So, number 1, guided practice. Find F of 4 if F of X equals X minus 6. So F of 4 means we're putting in a 4 wherever we see an X here. So that becomes 4 minus 6. So F of 4 is equal to negative 2. Okay, number 2, guys, choose 4 values for X to make a function table for F of X. Equals 8 minus X. All right, so we want our X and our Y. So I'll go negative 1, 0, 1, and 2. So 8 minus negative 1, 8 minus 0, 8 minus 1, A minus 2, that goes in for my rule, because that's what's happening as I substitute in and I begin to translate this function into something meaningful because I have a specific value of x. So minus a negative, so this becomes 9. This stays 8. This becomes 7. And this becomes 6. All right, number 3, oh boy. A hot air balloon can hold 90,000 cubic feet of air. It's being inflated at a rate of 6,000 cubic feet per minute. The total cubic feet of air is a function of the time in minutes. So our total cubic feet is a function of the time in minutes. And they tell us that we can do 6,000 cubic feet. So that's feet with an exponent 3 on its shoulder. So 6,000 cubic feet per minute. All right, so at this point, you don't actually really need the feet cubed. You just need to know that it kind of exists right there. It's going to be important for us as we get to the end of this problem. So 3a, identify the independent and dependent variables. So the independent variable is t, dependent variable is a, because a's value depends on whatever t is. All right, for b, what values of domain and range make sense for this situation? Well, if we're talking about anything in the real world, in particular something that's going to allow you to take off from the ground and fly in the air, you can't have negative values there, guys. You can start off with 0, right? After 0 minutes, you're not putting any kind of air into this hot air balloon, but you're not going to be putting negative air into it. So domain and range are both going to need to be greater than or equal to 0 for domain and range. That's what makes sense. Now, C represents the total amount of air by writing a function. But we already did that. Right? We're trying to make sense using our problem-solving strategies, understand, plan, carry out the plan, check to see if your answer makes sense. So we did that part of it. Then determine the total amount of air in 6 minutes. All right, so that means they want A of 6 is equal to 6,000 times 6, which is equal to 36,000 cubic feet. All right, the whole 90,000 cubic feet of air, now that's going to pop up a little bit down here in B, because what's going to happen with domain and range is that if the hot air balloon can only hold 90,000 cubic feet of air, then you're going to rise from 0 up to 90,000. All right, so you're not going to be able to go beyond 90,000 right there for your range. So that's where it's going to come up. In terms of part C, it's just a little bit of a red herring, right? Something that can trip you up because it's not appropriate for A or C, it's appropriate for part B. All right, we have a lot of room right here now for number 4, so we'll take a look at that here. How does the domain affect the range in a function? All right, well, we looked at that. Because D is really our independent variable. Our range is really our dependent variable. All right, so we're talking about X and Y. And we have some kind of a function rule that relates the two together. So f of X equals something. All right, so in a way, it's almost like a vending machine. Right, if you guys, I've been eating Fritos this week. So say you wanted a bag of Fritos, right? So you take a coin and you stick your money in the slot. Right? Stick your money in the slot, and what happens? You put the money in the slot, press the button for the Fritos, and the Fritos corn chips, they come out of the vending machine. Right, guys? So that's what's going on here. We get something that doesn't need to be defined by something else. So we get a specific value for x, doesn't matter, right, if it's really negative, doesn't matter if it's 0, doesn't matter if it's a little positive or, insanely positive. We're going to take this value, we're going to substitute it in to our rule, right? Our rule's like a little machine, and once we substitute this value into the machine, right, what pops out is our output. So we have here we go. Let me take the arrow and put it in here. So we have the input, goes through our little machine, comes out here, and it becomes our y. So that's how the two are related. So we can take an x value, we can get specific with it, we substitute it into our function rule, and as we work x through our function rule and perform our arithmetic operations, that's going to generate some sort of defined output value. All right, so I'll come back, I'll make some more videos for us. This is just first 4 pages, so hopefully you guys did well with this today.